Here we'll look at an example of sketching a graph starting with a parent function y equals radical x and going through various transformations to finally come up with the sketch for the function y equals -3 radical x plus 1 plus 2. So we start off with the basic parent function y equals radical x. Y equals radical x looks like this. It passes through 0, 0, which means if you plug in x equals 0, you get y equals 0. So that's one point on the graph. When you plug in x equals 1, we get y equals 1. So 1, 1 is another point on the graph. And the general shape of the graph, if we know the general shape, then we can sketch the graph that passes through 0, 0 and 1, 1. So that's our basic parent function. Next, let's reflect the graph across the x-axis. So when we reflect the graph across the x-axis, the point 0, 0 remains where it is, but the point 1, 1, so this was the point 1, 1, gets reflected across the x-axis and it becomes 1, -1. So when we reflect across the x-axis, y changes to -y, which means 1 changes to -1. So that's how we get 1, -1. So the graph, the shape doesn't change. Now it gets reflected across the x-axis and the new graph passes through 0, 0 and 1, -1. So that's the graph of y equals negative radical x. So our first transformation is reflecting across the x-axis. Our third transformation. So we're going to now multiply the function, the previous function, y equals negative radical x by 3. And this results in a vertical stretch by a factor of 3. It's a vertical stretch by a factor of 3. So the point 0, 0 remains where it is because when we multiply the y coordinate, since it's vertical, we multiply the y coordinate by 3. So that remains 0, 0. The point 1, -1, so we're looking at the point 1, -1, becomes 1, -3 when we multiply the y coordinate by 3. The y coordinate is -1, multiplied by 3, it becomes -3. And we're doing the multiplication by 3 because we want to stretch it vertically by a factor of 3. So now we have the equation. At this point, we have the equation y equals -3 radical x. Our next step, so that's step number 4, we shift the graph, since we're changing x to x plus 1, we shift the graph to the left by 1 unit. 0, 0 changes to, when we shift the graph to the left, we subtract 1 from the x coordinate. It becomes -1, 0. Our second point, 1, -3, when shifted to the left by 1 unit, since moving to the left is a horizontal shift, we subtract 1 from the x coordinate. If it's a horizontal shift, subtract from the x coordinate. If it's a vertical change, the y coordinate gets affected. So our new coordinates are -1, 0, which is the starting point of the graph, and it also passes through 0, -3. The shape remains the same. Now finally, we need to add 1 to the previous equation, which means we shift the previous graph up by 2 units. So when we shift the point -1, 0 up by 2 units, when I say up, it's vertical, so the y coordinate gets affected. So we add 2 units to the y coordinate to get -1, 2. So when we shift the graph up, the x remains the same, the y increases by 2 units. Same thing here, 0, -3, the x remains the same when we shift it up. We add 2, when we shift it up by 2 units, we add 2 to the y coordinate to get 0, -1. We plot the points. The shape of the graph doesn't change except that it passes through these 2 points. So finally, we get the equation y equals -3 radical x plus 1 plus 2. Now let's quickly go over the various transformations. First, we graph the basic function y equals radical x. Next, we reflect the graph across the x-axis because there's a negative sign attached to the radical x, so that tells us that we have to reflect the graph across the x-axis. Now the third step is we multiply the function by 3, which means the transformation is a vertical stretch by a factor of 3 because we are multiplying with 3. The fourth step, we change x to x plus 1. So changing x to x plus 1, so everywhere you see an x plus 1. So we shift it to the left by 1 unit. So changing x to x plus 1, sorry, this is not a -1, would mean shifting the graph to the left by 1 unit. So shifting the graph to the left by 1 unit would mean subtracting 1 from the x coordinate. And finally, we have the fifth step, which is y equals -3 radical x plus 1, and then we add 2 to get the final equation. Adding 2 to the entire function would shift the graph up by 2 units. So all the x coordinates in the all the y coordinates in the previous step change, which means we have to add 2 since we're shifting up by 2 units. Add 2 to all the y coordinates. So this is our final graphs, and this is the sketch.